You are listening to Single Serves. My name is Arno Marture and I am your host. Single Serves is a podcast dealing with design, architecture, business, and city building in which I interview an expert on a specific subject matter. Together, we dive into that topic and challenge conventional thinking in a thought-provoking conversation. I sincerely hope that you will find these conversations as engaging as I did and learn a thing or two in the process. Don't forget to send us your comments, criticism, and praise. To do so, you can email us at hello@rvltr.studio or leave a comment online. You can also subscribe to the podcast on our website at rvltr.studio and follow us on social media under the handle at revelator_TO. It's REVELATEUR_TO. So today we have Carlos de Oliveira with us. Carlos is a structural engineer, inventor, designer, and entrepreneur, and he's also the co-founder of Cast Connex. He's a foremost expert in the design and use of steel castings in building and bridge construction. So thanks, Carlos, for being on the show. It's a great pleasure to have you.
Thanks very much for having me.
Can you tell us more about who you are and what you do?
Sure. Cast Connex is a buildings products company. We supply structural components for use in steel building structures and bridge structures. We have standardized components, and we also design bespoke or custom components for projects. Our components are often used in architecturally exposed structural steel, so that's connections and components that are exposed to view in the finished building condition. But we also design components for very heavily or arduously loaded connections in buildings and bridge structures.
And so can you tell us a little bit about how that business came about?
Sure. Cast Connex actually was a spin out from my master's research work and my business partner's doctoral work at the University of Toronto. So myself and my business partner, Michael Gray, we co-founded Cast Connex based on our research into how we could leverage steel casting manufacturing to address some very arduous connection types in building structures. Specifically, our research was around seismic resistant or earthquake resistant connections and how we can leverage casting manufacturing to simplify the design and construction of those types of connections and improve the structural performance of those types of connections. But ultimately, it was through that research that we identified some additional merits of casting manufacturing and ultimately decided to commercialize the ideas that we had developed and to create the business.
So at which point did you guys realize there was an opportunity for you to start a new kind of business or exploit a new type of niche?
It was actually our thesis supervisors, so Professor Jeff Packer and Konstantin Christopoulos. They were obviously our mentors and our supervisors, technical supervisors, and they felt that some of the concepts that we were developing with castings could have commercial potential, and so they encouraged us to file patents for the work that we were creating. And at first, we didn't really have any specific ideas or even perhaps desire to create a new business entity to be marketing these components. We thought we would just file patents and then license the patents to some magical industry player that would run off and pay us royalties, and we would just ride out into the sunset. But it was in discussions with various industry players talking about the intellectual property that we had developed. We kept hearing the same thing: was your ideas are great. They have a lot of merit. They've got legs. They provide a lot of benefit to the industry in terms of producing buildings that are safer, more economical, more resilient, more beautiful. But ultimately, we don't do castings, or that's not our bread and butter. Where that's not the type of products that we supply to the industry. And so it came to a point where we had to do a gut check and decide whether or not we really believed in what we had developed. And at that point, we said, look, if we can't find an industry player that's just going to license this and pay us royalties, then we're going to have to create our own business to market and sell these components. And that was probably one of the best decisions we ever made.
And so how is what you do disruptor in the marketplace?
So we design and manufacture cast steel components, and we sell our components to steel fabricators. So fabricators, what they do is they buy raw steel material, like say plate or wide flange I-beams, and they cut up those pieces of steel and they weld them together, and they put in the labor to increase the value of the structural steel so that they could then put it together like a mechanoset to make a building. So they're used to buying raw steel products and putting the value into them and creating the buildings or bridges that they're selling to their customers. So we come along and we say, hang on, rather than putting all that labor into the connections, we're going to give you a connection for you. And now all you have to do is weld our widget to the end of your steel member. So in a way, we're kind of eating their lunch. And so that's very disruptive to typical steel fabrication, where we're providing a pre-engineered product or an engineered product that replaces and in a way supplants some of the labor that they would have been putting into their work and selling it. Now, there's tremendous benefit to the components that we provide. I mean, not only are our components potentially more aesthetically pleasing or better looking, but our components also perform substantially better in terms of structural performance and longevity and resilience. And when the connections in the building are more resilient and stronger and stiffer, they provide tremendous benefit to the overall structural system. You can reduce the total tonnage of the structure. That structure will last longer. It will survive a larger earthquake, for example. And so sometimes when the contractors that we sell our components to push back against our products because we are in effect eating their lunch, the end user, the owner, the designers that are trying to design these structures, they're not necessarily able or understand like what's going on here. They just see a contractor pushing back against what would be a buyout item, and they're not necessarily understanding how that might impact the quality of the end result.
So why do you think being dominant in such a specialized niche is critical?
Globally, Cast Connex is the leader in designing and supplying castings for use in building structures. And with that level of renown, I think we have an ability to convincingly put forward the value of the components and the value of casting manufacturing. And so without being an industry leader, when we come along and we talk to our designer peers who are designing the building structures, that level of authority is important in terms of communicating a message that they could understand and that they would believe.
That's a very interesting thing, because as I'm sure you've noticed in the architecture and design industry, a lot of firms, that design and architecture firms, are very undifferentiated in the marketplace. They all kind of portray themselves as doing the same things or providing the same services. And there's, I think, a lack of understanding of the value of being differentiated for any kind of given expertise. So what do you think others could learn from your experience and you being in that position globally as the leader in what you do, or maybe having invented a sort of niche that you can then dominate?
Well, I think specialization can be an incredible tool for success. I'm a structural engineer. I could have gone and worked as any old structural engineering firm and been another structural engineer designing buildings, right? Or bridges. But instead, choosing to specialize has enabled me to elevate my practice and to be able to work on a global scale. We're really fortunate with the types of projects that we get involved with. We've worked with the Renzo Pianos and the Roger Stirk Harbors and Norman Fosters of the world, on projects all over the world. And here we are. We're only a 13-year-old company, spun out from my research. I could have never have hoped to have that kind of an impact on a global scale without having specialized in something. We were really fortunate to have hit on such a unique idea in our university research. Certainly it's not every day that you can do something like that, but we were I think very wise to choose to focus our practice in this way.
How do you envision the future of your company?
Well, I mean, we're growing every year since we started. We've never had a down year. We're growing in terms of the number of projects that we're involved with annually, the size of the projects, the types of projects. Our team is constantly growing. The number of manufacturing vendors that we work with is constantly growing. So I think we're going to continue along that trajectory. We do broaden our product offering. We're constantly investing in research and development and developing new products that are built on the platform of steel castings. And so, I think really the sky's the limit in terms of the potential of that platform and what we could bring to the building construction industry. We're part of it is part of our success, I think, is that we really believe in what we're doing and we're really passionate about it. And it's so easy to be passionate about something when what you do you feel like is improving the built environment, making buildings safer, making them more economical, simultaneously making them more beautiful and better places to be in. It's really easy then to become really passionate about what you're doing and to have that drive to push for continued excellence and growth.
Mm-hmm. And since you're a global leader in your niche, do you have to do a lot of outreach to get work, or are you at a point where most people just kind of find you and the work comes your way?
It's a sword that cuts two ways. Having developed something and being the party that's really bringing this relatively new technology to market, in one way, it becomes really easy to become the world's best at it because you're one of the few that are pushing this new technology. But on the other side is we're growing the market. We're having to build the market as we go. So it's not like we're walking in and there's already this tremendous market for what we're doing in the industry. We have to promote what we're doing. And it just so happens that we're among very few that actually do this.
So would it be fair to say that you have to promote what you do because most people don't even realize the potential of what you're offering? And so you have to kind of paint that picture in their mind?
Yes, yeah, we spend most of our marketing effort, if you will, is more education. So we go into engineering and architectural firms and we talk about the benefits of the casting manufacturing approach, what we can do differently. I mean, we freeform structural steel. We can make structural steel into any shape. And that has tremendous potential benefit from a performance perspective and an aesthetics perspective. I mean, we're all creatures of nature. And when we look at nature, we see things making sense. A tree is broadest at its base and gets narrow as you go up. And why is that? Well, that's because the forces that nature applies to a tree dictate that shape. And so when we design connections and components for buildings that are shaped in a sensible way, they're automatically beautiful, to us as natural beings, whereas conventional fabrication where you're just cutting plates and welding them together, you're holding a hammer and everything looks like a nail. You're kind of jamming it in a way that, you're putting the material there in a way that it'll work, and you're stitching it together and trying to work. We're like, no, start with a clean slate. What do the forces want that shape to be? And we can shape that structural component in such a way that it makes sense for the forces that flow through it. And then suddenly you're looking at something that looks very elegant. And our customers and clients are really excited to expose that connection, that critical junction, and celebrate it in the architecture of their projects.
A long time ago, I read this book called On Growth and Form by Darcy Thompson that most architects have read. And it talks about the structures found in nature and why they're that way. How much inspiration do you find from, let's say, the natural order, to be very broad?
Most of my teammates at Cast Connex would be laughing as you're asking that, because I'm always the one that walks into a meeting and starts talking about rose petals or bat wings. I'm kind of like a purist in that way. We're always trying to make sensible components. I mean, we're, in addition to just the forces that go through our components, we also think about how the contractors are actually going to put together the buildings. And so there's always, some sort of tectonic nature to what we're doing too, in terms of how the other elements are going to join to them, how those connections are going to be made in the fabricator's shop or in the field. So there's other like utilitarian constraints that we apply to our components, but ultimately the forces that are applied to those components are the primary driver of their shape. And really it is, it's a natural thing. Buildings look the way that they do because they have to resist the forces that are on them. We're fighting gravity, wind, and earthquakes. That's basically it.
So now that we have like huge amounts of computing power at our fingertips and all kinds of algorithms, do you ever evolve your design, or have you ever considered doing it?
Evolve, we've used something called topology optimization, which is, it kind of follows like an evolutionary consideration. So we have a design volume and we apply all the forces to it, and basically through iterative analysis, you slowly eat away the material that's not working hard, and you're left with a form or a shape that is really all that would be necessary to resist those forces, right? So that kind of approach we do employ sometimes, and we do use it to inform some of the shaping of our components. Ultimately, we don't leave things looking so incredibly skeletal. We tend to add back material to make things look a little more sculpted, and to be a little bit more practical from a casting manufacturing perspective, and other considerations like corrosion or coating system performance, etc. Right? Some other practical considerations. But yeah, we do let physics drive what we're doing.
What would you say is the biggest mistake you've made so far?
It's not really technical. I think it's more financial. I think when people always say you should invest in yourself and believe in yourself. I think looking back, I should have put more of my own money into this business when we first started. We're a products company, so there's a substantial upfront cost to creating an organization like ours in terms of tooling up for manufacturing, doing full-scale structural testing, securing regulatory approvals, etc. So we had to raise private equity financing to start our organization, and I should have taken more loans and hung on to a greater share of the company.
Where can we buy share of your company?
We're privately held. We're not traded on the stock markets.
Make sure you let me know once you have your IPO. So going back to that mistake, what's the lesson you've learned from it, or lessons?
Like very generally, I would say everyone should really believe in themselves and invest in themselves. I mean, clearly I had some element of that. We believed in ourselves enough to take the step of starting our own organization and investing ourselves into creating something from nothing. But if I think the kernel of truth there is believe in yourself, and you really have nothing to lose when you take that kind of a chance, right? I mean, worst case scenario is you lose some money, but the experience that you've gained and in your life is tremendously worth it.
Since you've started, because you said you've been doing that for 13 years, so it's been a while. Have you seen any competitors emerging, trying to emulate you, copy you, surpass you?
Yeah, over the years, we've had a few small outfits that kind of start up and try and compete with us, but for the most part, they haven't been successful. I have my own ideas as to what mistakes that they've made, over time that didn't allow them to get to the stage that we're at. There's also, other types of systems or approaches and structures that would compete, maybe not so directly, but we would consider some form of competition. There's a lot of different ways to skin a cat, as they say. So, there's different ways to build buildings and structures. To be honest, when I think about competition for our company, I don't think about other companies that do what we do. I think about the status quo as being our biggest competitor. So that typical mindset that, no, we've been doing steel structures or connections and structures this way for years, and this is how it's done. That's our competition, breaking that mindset and showing, being able to show the value that our solution brings holistically to the whole project. That's always been our biggest challenge.
So when you're facing with prospects like that who don't really understand the value of what you do you ever walk away from this? How often do you say no to projects?
What I like to preach within our organization is I want our team to be the one to tell our customers when we don't think it's a good fit. I always tell my technical sales team that we're in this for the long haul. We're not in this for the short-term gain. And so if you're working with a design team and we don't think that our approach or our solution provides enough value, I want to be the ones to tell them that, because the type of credibility that offers and builds for the organization is worth it 100 times over rather than just going for the short-term gain of the one project that was just kind of mediocre for the customer.
And you seem to have a very refined, and I don't mean to be condescending when I say that, it's just an observation, but you seem to have a very refined sense of business, very acutely aware of all the things that are happening and the challenges. Where do you get that from? Are you self-taught? Did you take business courses?
My educational background is just in structural engineering. So I had, bachelor's and master's degree in structural engineering. I don't have any formal business training. I would say that entrepreneurship does run in my family. My father's an entrepreneur, and growing up, he would always tell me it's way better to work for yourself than to work for anyone else. And so there was, from an entrepreneurial perspective, I probably inherited or learned that drive from him. But in terms of, business acumen, I don't know that I would agree with you, but I would say that everything I've learned has really been trial by fire.
Well, that's the best way to learn. What would be the one biggest lesson that you've learned from your father as an entrepreneur?
I think it was, that hard work pays. Putting in the time and effort to deliver, quality products or quality service is worth it. And that it's really a marathon. It's not a race. It's a long race, right? And so, focus on the long term, I think, are some of the lessons that I probably learned from my father. I'd also say, in terms of nuggets of advice, is, surround yourself with people that are smarter than you. I did say I learned everything about business as trial by fire, but I also should say that we were really fortunate to get involved with some early seed investors that provided just so much support beyond just the financing. I have a spectacular board of directors that is, made up of industry professionals in steel fabrication, steel making, architecture, and engineering. And it's tremendously valuable to bounce ideas off of them and to be open to their suggestions.
What would be the one or two opportunities that you see are still unfulfilled in the architecture and construction industry, or maybe you're exploring for the future, but things that maybe you've seen and haven't been perceived by anyone else?
I think something that gets that's a buzzword that a lot of people talk about, but I don't think that has been implemented properly, is modularization. Everyone talks about modular construction and pre-construction, and I really don't think that has really taken hold through the whole steel construction industry. Every steel fabricator that we interact with, they always think about every project as a one-off. Whereas, in the shop, if you walk through the shop, you see they're repeatedly doing similar things for every single project, but they're not thinking about it in that same kind of macro scale. I think manufacturing, I think that steel fabricators should be thinking themselves more as manufacturers rather than as like bespoke fabricators for this building or that building. There's much more opportunity for modularization than is currently out there. And that's probably because part of what we do is also make standardized components for building structures. So obviously I have my own biases, but
yeah. And so in what I've learned about your business, there's kind of two sides. There's the one-off custom type of work for high-profile projects and the more modular repeated components. What does each represent in terms of percentage of your activity?
Well, it ranges dramatically from year to year, to be honest. Some years it's mostly standardized components, and then other years we're involved in a number of very large and significant projects that would require custom design components. From an effort perspective, I can tell you without a doubt that the custom design components require significantly more effort. From a financial perspective, our standardized components require inventory and warehousing and supply chain management on a very different level than when we're making bespoke components. So there are different aspects and different challenges for each.
What is the one building you wish you would have worked on or maybe designed some components for in the entire world?
In any time in history or modern history?
Any time in history.
I wish I could have been around and worked on the Eiffel Tower.
That's a good one, which is also an interesting choice because it was really hated when it first opened. And now it's one of the most revered landmarks in the world.
Yeah, well, I mean, as a steel guy, as I like to think of myself, participating in the steel construction industry, you just look at that structure and it is what it is. It's bare bones. It's sitting there. Its form is driven by, its purpose and the loads that are on it. And I think it's just really elegant in the way that it is.
I would agree with you. I have an affinity for the Pompidou Center also in Paris because I've always been fascinated by the structural system that they've come up with to build this thing that still looks crazy almost 50 years later.
It's funny you should mention that one because that was actually one of the very first projects in history to feature steel castings pretty extensively through the entire design. And we often talk about what we're doing as being so innovative and new, but really it's been around for a long time. It's just not very many designers have really grasped onto it and taken it as far as we have.
Well, we have Peter Rice to thank for that.
For sure.
May his soul rest in peace. That's it for the interview. Thank you very much for your thorough and candid answers.
Thanks very much for having me.
I look forward to many more of those conversations.
You too.
Hey, Arno here. I hope you've enjoyed this episode and that you'll come back for more. Please share with your friends and colleagues and remember to subscribe on our website at rvltr.studio. Until next time, ciao.